The ability of the metals to be drawn into wires is called ductility. Gold is the most ductile material. You will be surprised to know that a wire of about 2 km length can be drawn from 1 gram of gold. It is because of their malleability and ductility that metals can be given different shapes according to our needs. You must have seen that the wires that carry current in our homes have a coating of polyvinyl chloride, PVC, or a rubber-like material. Why are electric wires coated with such substances? In previous class, you had seen that very few non-metals are compared to metals. Some of the examples of non-metals are carbon, sulfur, iodine, hydrogen. The non-metals are either solids or gas except bromine, which is a liquid. All metals except mercury exist as solids at room temperature. Metals have high melting points, but gallium and cesium have very low melting points. These two metals will melt if you keep them on your palm. Iodine is a non-metal, but it is lustrous. Carbon is a non-metal that can exist in different forms. Each form is called as an allotrope. Diamond, an allotrope of carbon, is the hardest natural substance known and a very high carbon boiling point. Graphite, another allotrope of carbon, is a conductor of electricity. Alkali metals, lithium, sodium, potassium, are so soft that can be cut with a knife. They have low densities and low melting points. Most non-metals produce acidic oxides when dissolved in water. On the other hand, most metals give rise to basic oxides. All metals combine with oxygen to form metal oxides. Metal plus oxygen, metal oxide. For example, when copper is heated in air, it combines with oxygen to form copper 2 oxide or black oxide. 2Cu plus O2 gives 2CuO, copper 2 oxide. Similarly, aluminum forms aluminum oxide. 4Al plus 3O2 gives 2Al2O3 aluminum oxide. For some metals such as aluminum oxide, zinc oxide show both acidic as well as basic behavior. Such metal oxides which react with both acids as well as bases to produce salts and water are known as amphoteric acids. The aluminum oxide reacts in the following manner with acids and bases. Al2O3 plus 6HCl gives AlCl3 plus H2O, Al2CO3, Al2O3 plus NaOH gives NaAlO2 sodium aluminate plus water. Most metals are insoluble in water, but some of them dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolved in water to produce alkalis. Metals such as potassium and sodium react vigorously that they catch fire if they kept in open. Hence, to protect when driven from accident fires, they are kept immersed in kerosene at ordinary temperature. The surface of metals such as magnesium, aluminum, lead, etc. are covered with a thin layer of oxide. Protective oxide prevents the metal from further oxidation. Does not burn on heating, but iron films burn vigorously when spent in the flame on the burner. Copper does not burn, but the hot metal coated with a black layer of copper 2 oxide. Silver and gold do not react with oxygen even at high temperatures. Anodizing is a process of forming a thick layer of aluminum. Aluminum develops a thin oxide layer when exposed to air. Aluminum oxide coat then makes it resistant to further corrosion. The resistance can be further improved by making the oxide layer thicker. During anodizing and clean aluminum oxide articles made the anode and is electrolyzed with dilute sulfuric acid. The oxygen gas at the anode reacts with aluminum to make a thick protective oxide layer. The oxide layer can be dyed easily to give aluminum articles to an attractive finish. The reaction of magnesium is less vigorous, implying that it is not as reactive as sodium, but burning in oxygen does not help. Plus, the key side of both the reactivity to zinc, iron, copper, or lead. Metals react with water and produce a metal oxide and hydrogen gas. Metal oxides are soluble in water, dissolve in it to form further metal hydroxide. But all metals do not react with water. Metals like sodium and potassium react violently with cold water. In case of sodium and potassium, the reaction is violent and exothermic. Later, evolved hydrogen immediately catches fire. The reaction of calcium with water is less violent. The fuel is not as sufficient for the hydrogen to get fire. Calcium starts floating because the bubbles of hydrogen form stick to the surface of the material. Magnesium does not react with cold water. It reacts with hot water to form magnesium oxide and hydrogen, magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to the surface. Metals like aluminum, iron, and zinc do not react either with cold or hot water, but they react with steam to form the metal oxide and hydrogen. Metal plus dilute oxide gives salt plus hydrogen. Hydrogen gas is not evolved when a metal reacts with nitric acid. Nitric acid HNO3 is a strong oxidizing agent. It oxidizes the H2 produced in and itself gets reduced to any of the hydrogen. Nitrogen oxides and NO2, but magnesium and manganese react with very dilute nitric acid to give hydrogen gas. The reactivity decreases in the order magnesium, aluminum, zinc, iron.